Today we discussed about polarization. What is polarization? All these things you need to understand. First, we need to understand what is electromagnetic wave. In that wave, electric and magnetic field will be mutually perpendicular. See this, light ray is traveling in this direction. And electric field is vibrating in the plane of the screen, up and down. Blue color is magnetic field. Magnetic field is perpendicular to the screen. You have to understand that. In general, when we deal with light, maybe a lens or mirror, there we don't have a single light ray. There are multiple light rays. Assume one more light ray, just both are parallel to each other. But is it necessary for both the light rays? Electric field should vibrate in the plane of the paper, because I don't know whether you can feel it or not, this entire thing may be slightly rotated, or it can be rotated in any angle. Can you understand? That's the point. So there is no rule that this and this exactly vibrate in same plane. For one, it is vibrating in the screen. For the other one, it is vibrating perpendicular to the screen. Possible, na? This possibility of having different angle, if you understand, it can be any angle. Electric field can vibrate in any angle. If you start understanding this, instead of taking electric and magnetic fields, if you take one at a time, it is better to understand. So for all mathematical or understanding purpose, I can say, we use only electric field. For time being, what we do is that we remove magnetic field. Now, same electromagnetic wave looks like this. Are you convinced? Sir, magnetic field is not there. No. Magnetic field is there. But we are considering only electric field to understand, because always they're confusing. Now, if I look at this from one side like this, exactly, one light ray, electric field is vibrating like this. For one light ray, electric field may be vibrating perpendicular. One light ray is some angle. So if you look through the line where the light ray is traveling, if you observe closely, we have all possible cases. So how to explain, I don't know, because it is three-dimensional. It's tough. You have to imagine. Now, if I make the light ray, it will be like this, vibrations. That means the person who is observing electromagnetic wave or light, the person who is observing, the electric field can vibrate up and down with some angle like this, with some angle like this, like this. It can be any angle, right or wrong? Of course, I made only one vibration, 2, 3, 4, 5 I made. It can vibrate in all possible angles. One light ray may be like this, one may be like this, one may be like this. This is the thing. Now, we try to understand concept by using a mechanical experiment. Sir, what is that mechanical experiment? I'll explain. Assume that there is a string and cardboard or wooden piece also you can take. There is a cardboard like this, and there is a narrow hole like this. And this string is passing through it, and it is perpendicular. How it looks? It looks like this. Are you able to understand side view? The string is passing through the cardboard. Now, if you start vibrating it, the wave will be generated on the string. The wave will be like this. Are you able to understand? Sir, why this part is missing? It's behind the the cardboard. That's why. Now wave will travel forward. Any doubt? If I vibrate like this, the wave continuously moves. There is no issue at all. Now, if I rotate this cardboard by 90 degrees, now slit is horizontal. It looks like some angle, but it is exactly horizontal, and vibration is vertical. If I vibrate the string left-hand side will vibrate until this point. At this point, slit is horizontal, and the vibrations are vertical, nothing comes out. Because when the particle is vibrating up and down, slit is also vertical, up and down, the wave will travel. when the slit is perpendicular to it, wave won't travel. All other properties means reflection, refraction, diffraction, and all other properties of transverse wave will be there with longitudinal. Longitudinal will be having transverse. Both are having all the properties. Only unique property of transverse wave is polarization. If this property is not there, you cannot distinguish between longitudinal and transverse unless you see something there. Maybe vibration string you can see and you can distinguish. But other cases, some case where you can't see the wave with your eyes, then this is the only property which can distinguish between transverse and longitudinal. This property is shown by light. That's why light is a transverse wave. Theoretically, it is being proved. That's a different story. But experimentally, we proved it. Normal representation of light ray is not sufficient for us. Right now, you are representing light ray. You are not giving any clarity about how the electric field is vibrating. Now, onwards, I added a new word that's called as plane of vibration. In this case, what is plane of vibration? Tell me. The screen itself is the plane of vibration. A wave can vibrate in the plane or perpendicular to the plane. It can vibrate in any plane, all 360. Now, how can we indicate that onto this light ray? That's a serious question here. How do we represent? All the vibrations will be represented in two mutually perpendicular axes. Let us make axis here. We represent all the vibration in this mutually perpendicular axis. Sir, my question is, what about this vibration? Don't worry. This vibration can be resolved into horizontal, vertical. Sir, can we resolve vibration? It is nothing but electric field. Definitely you can resolve. And we represent that like this. This is in plane vibration. Means what? Like this. Vibrating in the plane of the paper or screen, then we vibrate like this. You can see that arrows are in the plane. Okay, sir, this part is easy understood. How do you represent perpendicular to the plane? Think about it, an arrow is coming towards you, how it looks like a dot. Or think about a pencil is there, the pencil is coming towards you. You can see the tip of the pencil, dot. So, dots. Concentrate. These dots represent out of plane vibration. These arrows will indicate in plane vibration. This is how we represent light for the purpose of this polarization concept. In case of normal ray optics, we don't need to care about vibration. So this is sufficient. But here that is not sufficient. We have to go for this. Okay, sir, good. What is these vibrations? 100% electric field only. What about magnetic field? We don't consider. Will be there, 100% will be there. Sir, that does means you are speaking in a single light ray itself, all vibrations are there. No. This is not, I can say this is not representing a single wave. This is representing bunch of waves. Take it like that. One vibration will be like this, one will be perpendicular, one will be with some angle. What we did is that we resolved all possible vibrations into two mutually perpendicular, in plane, outer plane. We represent like this. And this is bunch of light rays. And this is called as unpolarized light. Sir, what is unpolarized? Then what is polarization? See, if you take all the light rays, if you make sure all these light rays will vibrate only one plane, because here all possible planes are there, 360 degrees. If you make it to vibrate only one plane, then it is called as plane polarized light. Take the perpendicular plane, like this it is. Sir, these arrows are missing. Yes, they are missing because in that plane it is not vibrating. Only perpendicular plane is vibrating. This is polarized light. So that's the only polarized light. It can be any plane. This is also plane polarized light. Anyone is there who can tell me how it is plane polarized light? how this is not plane polarized. Dots are missing, check it. Dots are missing means what? Only in plane vibration is there, outer plane vibration is not there. Now, let us imagine a plane like this, which is perpendicular, passing through the light ray, and one more in the plane. The plane which is perpendicular to the plane of vibration is called as plane of polarization. This is plane of polarization. That means in that plane there is no vibration. The other one, dotted one, is that plane of vibration, the plane in which electric field is vibrating. Let us take a small test. If you look at this light ray from this end, what is the vibration, how it looks? Observe, unpolarized light, I made diagram like this. If I look at here, it can, the electric field can vibrate like this, or like this, or with some angle. All possible angles are there. If I look at this, like, what will be the vibration of electric field? It will be like this, only this vibration. Similarly, if you take the other light ray, vibration will be only vertical. Okay. So this is what you need to understand, because these kind of things will give you clarity about what is polarization and all these things. Now, the second question will be, okay, sir, what is there in the syllabus in polarization? How to produce plane polarized light? Polarization by reflection. Let us assume two media interface. There are two different media. One is air, other is in some medium. Light ray is incident here. Observe, we have dots also, we have arrows also. It is unpolarized light. When the light ray, which is unpolarized, hits the two media interface, obviously light ray will reflect and refract. Reflected light ray will be like this. Refracted will be like this. So reflected, I was able to understand. It is crystal clear. Reflected is plane polarized, and vibrations are out of plane. I can understand that it's coming out of the plane. I can understand this one clearly. But what about this one? Is it unpolarized? I can say this is partially polarized. See, if you see the number of dots are less, but in the plane vibration is more. In general, vibrations are uniformly distributed. Means what? The vibrations in the plane and out of the plane both will 50-50%. But out of which you're taking some part of outer plane. That means in terms of numbers, I'll say, assume 50% in plane, 50% out of plane, incoming light. But out of 50%, around 10% of outer plane is being taken out. So transmitted light ray, by considering there is no energy loss, will have 50% in plane, only 40% out of plane. So this is partially polarized. Understood? This is partially polarized. But reflected will be 100% completely polarized. Now, we need to go through the standard stuff. Remember, all other standard things are there. Angle of incidence, I. Angle of reflection also same. Angle of refraction, R. All these things are there. So, polarization by reflection says that reflected light will be 100% plane polarized. Sir, will it happen at any angle? No. There is one particular angle. At that angle, only reflected light ray will be completely polarized. So, that angle is given by a law called as Brewster's law. And that angle of incidence is called as Brewster's angle. Okay. What is Brewster's law? Law is very simple. When reflected and refracted are perpendicular to each other, or reflected is perpendicular to refracted, then reflected light rays completely plane polarized. That means angle between these two is 90 degrees. So observe, this is I, this is 90, this is R. I plus R plus 90 is equal to 180. That implies I is equal to 90 minus R. Good. What we can do is that now we can use Snell's law. Snell's law says that sin I by sin R is equal to mu. If you use this one here, then sin I by cos I is equal to mu. That implies tan I is equal to mu. Now this angle of incidence, the light ray will be completely plane polarized, and this angle of incidence is called as Brewster's angle. We take second method to produce plane polarized light, polarization by selective absorption. Sir, what is this? There are some materials which will absorb selectively. Now, when you take light ray, it has both in plane, outer plane vibrations. Now, the material has special property. It will absorb more this in plane and it will allow more outer plane or vice versa. So, selectively it will absorb. This is called as polarization by selective absorption. That means if you make enough thickness, the metal will absorb one plane of vibration, other plane still will be there. You can produce this, and remember this is a big advantage because you can produce in mass. Computer screen, if it is LCD screen, not LED, LCD screen that you are observing has a sheet of polarizer. Okay. Now this property of the metal is called as dichroism, and this is widely used and it is less expensive. Anywhere, wherever there is a liquid crystal display, it will be there. The diagram will be like this. This is how dichroism will be. Diagram is not utter perfect, but still good. Light rays coming in. It has all possible vibrations. But this material has the property of dichroism. Dichroism is nothing but polarization by selective absorption. It will absorb only, let us assume this is x-axis, y-axis. Okay. It will absorb only x-axis. Y also it will absorb, but slight. X will be almost completely it is absorbed. If you have enough thickness, it will absorb completely. Now, whatever light ray is coming out will be vibrate only one plane. So, unpolarized light to polarized light. This is dichroism. The phenomenon is called dichroism and polarization by selective absorption. Sir, what is this arrow? This arrow indicates you will get vibrations in that plane only. Now, you produce plane polarized light by using dichroism or any method, maybe reflection or any other methods. Ultimately, you are producing plane polarized light, right? The device which is used to produce plane polarized light is called as polarizer. There are two words which are confusing. This material which use dichroism to produce plane polarized light is called as Polaroid. Understand the difference between Polaroid and polarizer. Polaroid is polarizer, but Polaroid is not only the polarizer. There are many ways we can produce plane polarized light. Example, Nicol prism. Polarization by reflection. You can use any method to produce polarized light. The device which will produce plane polarized light from unpolarized light is called as polarizer. But the device which produce plane polarized light by using dichroism or polarization by selective absorption is called as Polaroid. So Polaroid is also, you can take it as polarizer. Wait, there is one more word you need to understand, that is analyzer. Sir, what is this analyzer? Now observe, you have a light, but by simply looking into it, you cannot say it is polarized or not. To understand whether it is polarized or not, what we do is that we take one polarizer only, we'll keep it here and we start rotating. When you keep exactly like this, both are having same plane of vibration, then you can see entire light. When you start rotating it at 90 degrees, what happens? Tell me. Nothing comes out because this will allow only vertical vibration. I took a copy of it and rotated by 90 degrees, it will allow only horizontal. In the incoming light ray, there is no horizontal light. So by rotating from 0 to 90, or in fact 180, you can see the light is maximum to 0, 0 to maximum once again. In that way, if you rotate and conclude, yes, this is a plane polarized light, at that position, the device name is called as analyzer. Polarizer, analyzer, both are same device. But where you use polarizer means from unpolarized light, you are producing plane polarized light. That is polarizer. Now, after this, to check this light ray whether it is polarized or not, you are using second time and you're rotating and checking it. Analyzer, polarizer, analyzer. Now, it can be any device. Let us use the word Nicol prism also. Nicol prism. So these two are the things which will produce plane polarized light. So when you use these to any one of the device to produce plane polarized light at that position, that is called as polarizer. If you use it to test, this is called as what? Analyzer. Whether it is Nicol prism or Polaroid, we try to make a single diagram. This diagram we're going to make. Sir, is it Nicol prism or Polaroid? Anything you can take. Sir, what does this line indicates? The line indicates line of vibration. That means it will allow this vibration. Is clear? Left hand side, we have unpolarized light. But when you look into the right hand side, we have only plane polarized light. Right now, this is called as polarizer. After this, if you take one more, if you keep it here, and when you rotate 360 degrees, light will go to maximum intensity to minimum to maximum again. This is called as analyzer. Unpolarized light to polarized light, intensity will be by 2.